Okay, in that case, we start module 5. Of course, module 5 is part of test 3. Okay, so module 5 and then in module 6, they will be part of test 3, which is coming up very soon. Okay, so a few terminology, few key words, I would call them. First of all, there is something called polynomials. What is a polynomial? A polynomial is a sum or a difference of terms. Now, let me refresh your memory. What is a term? For example, 2x plus 1. These are terms. And this expression has two terms. Because quantities are either added or subtracted. Now, if we look at 4xy squared, this is one term, and every piece of the term is called a factor. This is a factor, this is a factor, and this is a factor. Same thing here, 2 and x. They are factors because they are connected by multiplication. But when we start adding or subtracting, we're not adding and subtracting factors, we're adding and subtracting terms. So this is a big umbrella, very big umbrella of expressions or functions. Now the first three, monomial, binomial, and trinomial, they are the simplest polynomials. All these are polynomials. We call a monomial an expression that has only one term. It's a polynomial, but it specifically consists of one term. Binomial is a polynomial specifically with two terms, exactly two terms. Of course, trinomial has three terms, and from that moment on, 4 or more, we don't have special names. We call them just polynomials with 4 terms, or polynomial with 5 terms, or polynomial with 10 terms. But the first three, the simplest ones, we have specific names. Do I have to use monomial? But I need to know what it means. So a polynomial with one term is called monomial. A polynomial with 2 terms is called binomial. With 3 terms is called trinomial. Beyond that, just a polynomial. Okay, so here is an example, and we had something like this before. 4x to the 4th minus 3x squared plus 5x minus 10. This is a polynomial. Can anyone tell us how many terms does it have?
4.
Yes, indeed, it has 4 terms. Can anyone tell us whether this polynomial is arranged in descending? Descending means going down. Descending order. Descending order of the powers of the variable of x. Is it true? Is it true that this polynomial is arranged in descending order of the powers of the variable?
Yes.
Yes, it is. Power 4, power 2, power 1, and power 0 for x. Why don't I write power 0? Anyone remembers what is a number raised to 0? What does it equal to, assuming that the number is not 0? This is an important topic. We need to remember it. Anything raised to 0 is la la la. except 0 raised to 0.
0.
0 raised to 0. So you're saying that x raised to 0 is 0? The answer is 1. So that, remember, these are new things that we need to repeat and repeat and review and review. That's why I'm kindly asking everyone to redo the notes first. So any number raised to power 0 equals 1. As long as this number is not 0. 0 raised to 0 is not 1. So that's the reason why we don't write it, because it's 1. So negative 10 times 1 is still negative 10. That's the reason why we don't write this. So again, power 4, as you see, power 3 is missing. There is no x to the third here. So power 4 is here, power 3 is missing, power 2 is here, power 1 is here, and power 0 is here. Good. Anybody remembers what is the degree? How do we determine the degree of this polynomial? This one. What is the leading term and the leading coefficient for this polynomial? Anybody remembers this?
Degree would be 4.
The degree will be 4. Is the degree that is the highest. We are not adding degrees. It's the highest degree. This degree is transferred over the entire polynomial. So this is degree 4, the whole thing. Very good. Thank you, Rachel. Leading term.
4x quad.
4x to the 4th power. Excellent. It's the most powerful term. It's called leading. Very good.
4.
Yes. The leading coefficient is the number in front of the x term. That is the leading term. Yes. Perfect. So this is the term that leads because it transfers its degree over the entire polynomial. This is the term that is leading, and this is the coefficient of the leading term. Very good. Now, we already know and understand how to determine the degree of a polynomial. First, we arrange it in descending order. Then we looked at the most powerful term because the degree is there, and that's the highest power of the variable. Now, polynomials do not have expressions with x in the denominator. So 1 over x is not a polynomial. So if you see an expression like this, and I am going to ask you, is this a polynomial? 1 over x plus 3x squared. You will have to say not a polynomial. A polynomial cannot have x in the denominator. That's not allowed. So please remember that. Because basically this is power x to negative 1. 1 over x is power negative 1. So all powers of the variables or variable in a polynomial have to be natural numbers, including 0. So if you want whole numbers, okay? Not negative numbers. Good. So again, we know how to determine the degree of a polynomial. But how do I determine the degree of a monomial? And you can say, but a monomial is a polynomial. You just mentioned that we know how to find the degree of polynomials. True. However, let's identify the situation that is specific to monomial, which means if I have 3x to the 4th y squared, how do I determine the degree here? I have to add the, let's say 3 cubed. I have to add only the powers of variables. I don't care what is the power of the coefficient. So this is degree 6. Why? Power 4 for x, power 2 for y, 4 plus 2 is 6. Okay, but then now how do I determine the degree of something like this? Let's say 2xy plus 2x cubed y plus 3xy to the fourth. Okay, this is a polynomial. How do I determine the degree of this? Exactly in the same way. I look at this monomial and identify its degree. Can anyone give us the degree of this monomial only? Say it again. The degree of this is?
1.
1 plus 1. It has two variables. Both have power 1, so 1 plus 1 is 2. Moving on to the next one. The degree of this monomial. And forget about the rest. I'm just identifying the degrees of each monomial.
4.
Exactly. And finally, I want to identify the degree of the last one.
5.
Exactly. You can rearrange them if you like in the correct descending order. 3xy to the fourth plus 2x cubed y plus 2xy. And now can anyone identify the degree of the whole thing? Anyone, please?
Would that be 5?
Exactly. The degree is 5 because this is the leading term. 3 is the leading coefficient. And I do not add degrees. We do not add degrees of monomials. I did not add 4 to 2 to 1 to 0. No. When it comes to anything but anything that is not one term, so 2 terms or more, I only identify the highest and I put it first. And I present the whole thing in descending orders of the power of the variables. This is degree 5, this is degree 4, and this is degree 2. And this is the correct order. So now I identify the degree, again, of the entire polynomial, which is transferred from the degree of the leading term. The degree of the leading term is 5. The whole thing is 5. I'm not adding 5 plus 4 plus 2. No. I only add inside the monomial, but not inside the polynomial. Inside the monomial, yes, degree 5. Inside the monomial, yes, degree 4. Inside the monomial, yes, degree 2. But only the highest transfers its degree over the entire polynomial. Good? Moving on. Any questions? Please stop me. Any questions? Okay. So just to make sure, another example, 2 over x to the 5th plus 3, or what I said before, 1 over x, these are not polynomials. No polynomial can have x in the denominator. This is a polynomial, 1/2 x to the 3rd plus 2/3 x minus 1/4. That is a polynomial. No x is in the denominator. They have some coefficients, but the coefficients can be fractions, that's fine. But these two expressions have x in the denominator. These are called rational. They have a ratio, and there is x in the denominator. rational expressions. These, or this one, is a polynomial. Good. Is, let's say, x to 1 over 9 plus x to 1 over 3 minus 4 a polynomial? Not a polynomial. Why? Because the powers cannot be fractions. The powers can only be 0, 1, 2, 3, and so on and so forth. They cannot be fractions. They cannot be negative numbers. Good. Here's another question for you. If I want to add 8x to negative 20xy, question, are these two terms considered like terms? Are they considered like terms? Can we add or subtract them? In this case, subtract them. This is new. You have not seen this before. So it's okay if you're wrong.
I'd say no.
Absolutely not. Only if this one had an also an y. Yes, because they have to have the same variables, and the variables have to have the same powers. This one does not have y, so therefore these two terms are not like terms. They cannot be added or subtracted. Good. So now let's look at a few examples, like 3x plus 5x squared minus 7x plus 8x squared. First question, is this a polynomial?
Yes.
Yes, it is a polynomial, of course. I don't see x in the denominator. I don't see fractions as exponents. Everything is a term, a term, a term, a term, a term. That's nice. Good. Now, where do I start? Because I see like terms. But where is my starting point? My starting point has to be the degree. What will be the degree of this polynomial? I'm asked to combine like terms if I can and simplify it. Can anyone identify the degree on this? You only have to identify the degree of each, not add them, but find the degree of each, and then you will know where to start. So can anyone give us the degree of this polynomial? And then we'll know where to start.
3.
So, careful. What is the degree of this?
1.
What is the degree of this?
3. 2.
This is 2. The degree of this?
1.
And this one?
2.
2. We do not add degrees of terms. We add degrees inside of monomial only. So we add the powers only inside a monomial, not in terms. This plus this plus this, never. Only inside a monomial. So therefore, the degree of this polynomial is 2. That's where I have to start. So we have to start with these terms. because they are like terms. I can say 5 apples plus 8 apples. 5 apples plus 8 apples is 13 apples. Now I reached the next in line. Since I finished with degree 2, then I have to move on to degree 1. If it's there. If not, I have to skip. But it's there. So what will you say? 3 apples minus 7 apples. Or maybe I should choose something else. I used apples. 3 pencils minus 7 pencils. How much is that?
Negative 4 pencils.
Negative 4 pencils. This is it. So as you see, we started with 4 terms, and we simplified the polynomial to a binomial, 2 terms. Degree 2, leading term, 13x squared. Leading coefficient, 13. Good. Any questions so far? Please, any questions? Okay, let's add some polynomials, like 2x squared minus 7x plus 7 plus 5x squared plus 15x minus 20. You are going to see in Pearson polynomials presented like this in parentheses, because in front of the first group there is no sign. Mandatory, we know, we have to assume it's positive. The positive sign in front of the second group doesn't change anything. So my first step has to be 2x squared minus 7x plus 7 plus 5x squared plus 15x and minus 20. And let's take a moment, combine like terms, simplify, and see what we get. Please. 1 minute. Does anyone have a answer for us?